Hi everyone, what's up? All good? Great. Today we will be solving the question minimum number of burst balloons. So let's see what is this question saying. There are some spherical balloons tapped onto a flat wall that represents the XY plane. The balloons are represented as a 2D integer array points where point I is equals to x of start and x of end denotes a balloon whose horizontal diameter stretches between these 2 points, which you have been given as an input. Okay. I don't need to know the exact y coordinates of the balloon. Okay, great. Arrows can be shot up directly vertically in the positive y direction from different points along the x-axis. A balloon with x of start and x of end is burst by an arrow shot at x if you shot the arrow between these given 2 points. Okay. There is no limit on the number of arrows that can be shot. A short arrow keeps traveling up infinitely, bursting any balloons in its path. Okay. Given the array points, return the minimum number of arrows that must be shot to burst all balloons. So, what you have been given? You have been given an array of points where each point represents the start of the x and end of the y coordinate. Start and end of the x coordinate. Okay. So if there are any balloons in a line, then you have been given that if you shot an arrow, if there are any number of balloons, then it will shot all the balloons. A short arrow keeps traveling infinitely. So you need to shot all the balloons in minimum number of arrows and we need to return those minimum number of arrows. Okay, so let's see. So see, you have been given with this points arrays and see. You have been given with the balloons such that one balloon diameter extended from 1 to 6, 2 to 8, 7 to 12, and 10 to 16. Okay, so let's see how we can short it. So let's say if you short this balloon at this point, this balloon at this point, this balloon at this point, and this balloon at this point. Yeah, very good. You have shot all the balloons. But wait, you have used 4 arrows. So let's see, can we do it in less number of arrows? Okay, so okay. So let's see. If we shot at this point, yeah, you can see we have shot 2 balloons using 1 arrow. Okay. If we shot at this, so yeah, we have shot this balloon as well now. This. So yeah, we have shot all the balloons, but we have used 3 arrows now. So let's see, can we do it in more less number? So let's say if we shot at this point, and let's say if we shot at this point. Yeah, now we have done it only 2 arrows. Cool. So can we do it in less than 2 arrows? Can we shot it here? Can we shot it here? No, we cannot shoot in more or less than 2. So its output will be 2. So you can see what we are doing here. We are shooting the maximum number of overlapping points. Okay. We are shooting at the point where there are maximum number of overlapping balloons. Okay, now let's see another example. You can see here, there are no overlapping balloons. So we need to shoot all the balloons separately and we will be needing minimum number of 4 arrows for shooting all the balloons because none of the balloons are overlapping here. Okay, so now let's think how we can solve it. So let's say if we sort them according to the start time, not start time, it's a start coordinate. Okay. So let's say if we will sort the balloons according to the x start point of the x. Okay. So let's see. What we can see is if we sort the end point first, then we can make sure that the balloons overlapping at that point will also be short. But if we sort it by start time, so I cannot make sure that the balloons before this will be short. Okay. So let's try sorting it by end time. Okay. Now if we sort it by end time, so let's see here. I have just made a small change in the example. 1 to 6 becomes 1 to 17. just to show you one thing. Okay, so this is also here, yeah. Okay, so let's see if I have sorted according to the end time. So what will happen here is, let's say if this will be the first balloon which is in our array. So let's say we will short at the end point of this balloon. Okay. Now our arrow is at point 8. Now when we come at the second balloon end point, then what is it? It is 12. Now we will check for the position of the arrow. So our arrow is after its start point. It means this balloon must have also shortened. Now we come at 3. This is 16. Now we will again check for the arrow position. No, arrow is before its start point. So this balloon must have not been busted. So now we will bust this as well. Now our arrow will come at 16. Now we will check for the fourth balloon. It is 17. And we will again check for the arrow position. Whether it is after the start point of this. Yeah, it is after its start point. So yeah, simply this balloon is also already busted. So its answer will be 2. Because we are using one arrow to shoot it and then we are using another arrow to shoot this third balloon. Okay, now why I have changed the example? See, earlier our example, because with that example I will not be make you understand it why we are sorting it by end time, because with that example it was ending at 6. And either I have sorted by start time, then it will remain in 1, 2, 3, 4 order, and either I will have sorted it in according to end time, then it will also remain in this order only. Because in this example, the balloon which is occurring first also ending first. So that's why I have just made a small change to make its diameter to 17 to make you understand that why we are sorting it by end time. Okay, so yeah, this was, so let's see how we can code it. So simply, first of all, we need to sort it according to the end time. Sorry, not end time, it's end coordinate and x coordinate. And then our arrow position is at the end coordinate of first balloon. Now we will start checking for the second balloon. If our arrow position is before the start point, then yeah, this balloon have not been busted. Now we will bust this balloon and now our arrow will point at the end coordinate of that balloon and we will increase our number of arrows and at the end we will finally return our result. Simple. Now, what will be the time and space complexity for this? As we are sorting the array, so its time complexity will be big O of n log n. And as we are not using any extra space, but com sorting an array will takes an internal complexity of log n, so its space complexity will be big O of log n. So yeah, this was the whole approach for this question. I hope you get it. If you still have any doubts, you can post in the comment section. I will surely try to answer them. Till then, bye bye guys. See you soon in the next video.